So yeah, we've got the recording enabled. Let me just share my screen. Uh, am I audible? If somebody could, confirm that on chat.
Yeah, perfect.
Yes.
Okay, perfect. All right. I'm gonna, start off, with certain cybersecurity concepts. I'm assuming this is your revision class or, the last. So I'll start off with cyber kill chain, and yeah, once we finish a topic, you guys can send in your questions on chat or unmute and we can discuss about the topic. So what is cyber kill chain? Basically it is a model which is developed by Lockheed Martin, and it helps the security team understand how, from an attacker's perspective, how what are the steps he or she is gonna carry to accomplish in a cyber attack. And it has 7 phases, starting off with a recon and then moving to weaponization, delivery, exploitation, action, installation, command and control, and then to his last stage, which is actions and objective. So, in brief, if you're going to see for, let's say, a reconnaissance stage, it would mainly, the goal of this stage is basically to find a weakness by understanding your target. So mainly it is of two types. One is active and one is passive. Passive is information out of the internet, things like your company website. If you're targeting a specific company, let's say, you're gonna see their job listings, what is hosted on their company, what kind of infrastructure they have, based on their job listing, and based off information out on the on Google, there the domain details. That is something you can pivot off through passive recon. And active would be mostly running a scan on their IP space, port scanning, using a tool like Nmap to understand what ports are open, what services are they running, what versions of softwares are they running, and based on that, if there's any exploit on the internet which they can utilize. So how do we on a surface level, how do we try to uh, as a as an organization, how would you try to defend yourself from this? Would be um, things like having a social media acceptable use. That is, you don't post everything on the internet. If you're an employee of a certain organization, you don't there are certain organizations which don't allow posting of their office space, how their office is set up, and job listings. Companies tend to limit the job posting on what kind of solutions they use, uh, let's say software solutions or security solutions. That is one way organizations can protect themselves. Technical controls, um, you can use firewalls, IPS, IDS, and then disable unused ports. Honeypots is something which is a far-fetched you know thing. Not a lot of companies have something like a honeypot setup, because this would come under a very mature model of a security perspective from an organization. When most of them start off, they don't usually start off with a honeypot because it's very expensive and it requires a separate function to monitor them. And then goes blocking of third party VPN, Tor, proxy applications. uh, yeah, so mainly a recon stage is just to gather information about a victim, find his weakness, so you can move on to the next stage, that is the weaponization. In this stage, basically an attacker is trying to exploit a weakness which he found from his previous recon stage. And the tools I've listed out here, these are certain tools which can be used from a red team perspective or from a attacker threat actor perspective to create a weapon to facilitate his actions. So based on earlier recon, he's going to understand the infrastructure. Let's say if if he's trying to target a specific website and it is running a backend server which is an SQL database, uh, things like he would maybe try to see if an SQL vulnerability is you know exposed to that service, or run a port scan to understand what kind of services are there, and based of that, use one of these tools to work through it. How do you defend this phase? um, Mostly technical controls would again be patch management. From a defensive perspective, run vulnerability scans, see if anything is vulnerable to the internet, and patch them. Most of the organizations have, let's say, you know a policy of scanning for 30 once in 30 days. So yeah, that way they don't disrupt services, but also make sure that they are not vulnerable, and patch accordingly. Other controls would be restricting browser plugins or disabling JavaScript Office macros, which is, I think, by default at the moment. This is to reduce your attack surface. And having a good email security solution, IPS, your antivirus solution, MFA, two-factor authentication. That is something which should be a bare minimum these days. And logging is necessary so that you understand what is happening. But from a defensive perspective or a detection engineering perspective, logging helps you to create detections to understand if somebody is trying to do something malicious on your infrastructure. Through logs, you can create detections. So from a defensive perspective, these are things an organization can work through. Now, moving on to the next phase, which is the delivery phase, and this is where an attacker would try to find multiple avenues to deliver whatever uh, weapon he created based on the previous two stages of analysis. So here, um, an attacker would understand what kind of websites a user or an organization commonly visits. Let's say if he's targeting a specific function, let's say the engineering team, uh, they he would understand what kind of websites they're targeting through OSINT, through which he can deliver his weapon, something like a water holing attack. And the other ways would be phishing is mostly as per statistics, that's the most successful kind of attack, or through which delivery can be successful. It's more of like a spray and pray attack. And USBs, this is, I would say, a thing of the past, but it is again, it depends on your organization's policies. um, a rogue USBs, inserting rogue USBs, that is another way an attacker can gain foothold into your organization. So how would from a defensive perspective, policies which include enabling SPF and DKIM for email security, and disabling your USB on your on the corporate device, having an exception policy if somebody requires a USB to be used, because this can also be used. USB disabling is good in a way, from both perspectives, from an insider threat and from an external threats perspective as well, because uh, data leakage or exfiltration of data can happen from an insider as well through USB. So yeah, and by web filtering basically means you're using a firewall solution which can filter certain categories of websites and not allow internal users to have access to it. And DNS filtering and web filtering comes in the same criteria. So a DNS solution can basically prevent a certain lookup from happening before it even hits the uh, website. So if an organization hosts an internal DNS server, they can try DNS filtering as well. Now moving on, the main goal of this stage would basically be to deliver his weapon from through one of these means: websites, emails, USBs, social media. Yep. Next stage would be exploitation. Over here, the considering the the weapon has been successfully delivered. So now exploitation would happen based on what kind of a payload the attacker has tried to create. Um, it could be a malware, or it could be a macros, or a JavaScript, code. So based on that, an attacker can try to gain access to the environment. Now, how would we try to defend in this stage? Things like limiting access, something called as data execution prevention. So basically, it tries to you know prevent certain executions from certain directories, so that your important file directories, if you're talking about Windows, would be your C Windows directory. So users wouldn't have admin access to perform any actions on the C Windows directory, but they can do any actions on the C users directory. So you can create policies wherein where can users have control of certain applications. And this is where a good EDR solution also comes handy. Um, Based on when you have an EDR solution, it can detect certain exploits and certain ways of a certain malware based on heuristics or based on signatures. That is where IPS IDs also comes in. Um, so patient zero, what patient zero is basically the first victim which was compromised, or let's say an attacker sends a malware across. The first occurrence in an infrastructure is termed as patient zero, because that's where it was found first. And yeah, now from an attacker's perspective, his main idea is to gain access first in this stage, and then comes the phase of installation. Now in this phase, as yep, all right, in the installation phase, it's basically to have persistence, um, by which the attacker can try running in, you know uh, which would help in his next stage, which is command and control. How would we the ways to gain persistence would be making registry changes, having a remote access tool, uh, a metapreter session, which is basically creating a reverse shell, so that an attacker has access to the victim. running PowerShell, certain PowerShell commands. Now, how would we try to defend that? This would basically be, from role-based access control. So, in role-based access control, basically, if a certain user is not an admin, he basically does not get to use, have access to PowerShell. Uh, so, a PowerShell is basically disabled, and any admin-related activities, even on the command line, is disabled. uh, Registry changes, changing, adding a threat actor can change the registry. So there are certain paths wherein a threat actor can modify to gain persistence. That is, one would be, boot startup. That way, that when a restart occurs, the threat actor still has persistence because of a startup application or a browser extension. Through a browser extension, persistence can be achieved as well. Now, yeah, a basic EDR would be able to, you know, protect you from these kind of instances. And worst case, if it comes to a successful, installation, there is again, once your EDR basically, notifies you, or you have a SIM solution which has a detection which, triggers an alert saying that a certain directory has been changed, or, there is a persistence mechanism which is being observed. You can initiate a IR process, which we're gonna talk about later, and wherein you can reset or isolate or wipe the device based on the needs. Moving on to the next phase, that is command and control. Over here, basically, the system which now has already, which has gone through 6 phases of the kill chain, now is waiting for instructions from its main server on how what it needs to do next. Now, the way to defend this would basically be to have a defense in depth approach. So wherein you do segmentation of your network, and by segmentation I mean you have multiple subnets within your infrastructure, so that you air gap your network in a way. Let's say a HR function and an engineering function, and you know a, a sales function. These three functions can be operated on three different networks. So in a worst case instance, a certain function is being targeted, the attack remains only to that specific subnet, and it does not traverse, or it does not move to the other functions because it is air gapped. So you can control lateral movement, you know to an extent, by at least segmenting than not having segmentation on your network. Apart from that, your firewall, your EDR solution, your SIM solution, IPS, IDS, and then a next layer would be your application control, things like a WAF solution to you know protect from any application layer attacks. This way, you can stay guarded. Now, actions and objective for a specific threat actor would be, once he's moved through these many phases, it depends on what the motivation, or what kind of an attacker is, what his motivation is. Let's say if it is a, if it is a ransomware threat actor, his main motivation would just be to, you know, exfiltrate your data, decrypt, encrypt your data, and exfiltrate your data. One is, two ways: either hold a, pay a ransom and get your data back, or you sell the data. And so depending on that, you know depending on that, a threat actor basically completes his actions of. And how would you defend it? Now when it comes to uh, when we spoke about exfiltration, that's where a data loss prevention tool or a DLP tool can help, wherein you monitor certain things. Your EDR basically has a detection wherein it detects suspicious change in files, or let's say change in file names. Because whenever a ransomware software is installed and executed successfully, what happens is a lot of changes to files happen. So an EDR and a file integrity monitoring solution helps in identifying a lot of changes, which would, again, with help of detection, can be detected at an earlier stage of the ransomware phase. And you could isolate a specific host using your IR perspective. So this is where, again, segmentation helps. Now based on this, at this stage, the attacker can also try to move laterally, not at the actions on objective stage, but if he finds something else, he can try moving laterally to find another point of interest and carry on. This stage again moves on. you know it just goes on a circle basically. Again, he runs a scan on the network, does recon, finds an vulnerability on your infrastructure. And yeah, so this is you know cyber kill chain, but a little bit of detail into it. Does anybody have any questions before I move into the next one? All right. I'm gonna assume it. There's no questions. All right. Let's move to the next concept, which is MITRE attack. Now, I'd rather explain it by visiting the website itself. So just hold on. Okay. So what is the MITRE attack framework, and what is this acronym? Basically, this spells out the full form of attack is tactics, techniques, and common knowledge. And MITRE attack is considered to be a knowledge base for security teams to refer, basically an extension of your cyber kill chain. You would see, I think, more than 7 phases here, but a certain phase is broken down into two other phases. That's exactly why you would see, more than 7 phases, and it has techniques and tactics within it. So this is an extension of cyber kill chain, as I explained. What this basically does is, from a blue team perspective, or from a red team perspective, or an attacker's perspective, how can somebody try to you know understand each phase broken down into different techniques, and he can try, let's say, for recon. A threat actor can mainly used by security teams, but it is used by threat actors as well, to understand how to go across an infrastructure. So let's say, An example would be, I'm going to take a common example of phishing. So a recon when uh, coming to phishing would be to gather victims' identity information, and then information about the organization, network information, just to understand things, and using tools like, you know uh, an open source tool like Maltego to understand more about a specific person you're trying to target. If you're going to send out a, targeted phishing attack, now your initial access would be phishing once you understand it. And now from a blue team perspective, how can someone defend this? This is where you would check what kind of phishing it is, and based on that, how is the execution. If it is user execution for phishing, mostly it is a user execution. So you can come in here, and let's say you understand it's a URL or a link. You can open your go further and try to understand what are the ways you can defend, that is from a detection perspective. So a detection team would try to understand, let's say, network traffic, or by network traffic, your sim solution would have a threat intel subscription involved in it. So when users try to hit a malicious website, right, you would your threat intel solution would notify that a suspicious traffic has been detected. Now when you see that in volumes, and you have a detection which says, if there is a count of more than 5 malicious category URL visits, send the SOC team an alert. So now this is how, from a detection perspective, once an alert is sent, proactively, this is more like from a threat hunt perspective, a blue team member can understand, okay, there is a suspicious domain visit. Now he's going to start looking at email logs to see if any URL was delivered with this specific domain, and that way block the domain first, go ahead and quarantine the suspicious emails. Yeah. um, Through this phishing attack, you can move to other stages, that is persistence. Now how does a threat actor establish persistence? If a blue team member would like to know, how can persistence be achieved? um, One is browser extensions. You can come into auto start keys, that is, let's say, a common example would be your startup folder or registry run keys. How is that achieved? These are your 4 registry locations where persistence can be achieved. So even if a restart or a reboot happens, a threat actor still has access to your machine. And from an incident response perspective, I would be looking at you know these folders to understand what kind of changes have been made in the recent past. From the you do a timeline analysis from the day of attack, or from the day of patient zero was observed, and yep, initiate cleanup activity. So yeah, um, what is the difference? What would be a difference between the kill chain and the miter attack? The major difference is basically, miter attack is much more in depth and broken down into multiple aspects compared to a surface level, you know, um, a surface level perception of how an attacker tries to carry out a successful attack. So it helps teams understand in a deeper manner. Does anybody have any questions on the MITRE framework? And okay, I'm assuming it's a no. So if anybody's interested to go a little more deeper into the MITRE framework, or this would help from your preparation, let's say your interview preparation, understanding of MITRE framework is important because
How
from
we are going to map these MITRE TTPs tactics?
okay, uh, what do you mean by how we're going to map? uh,
Yep.
all right, okay,
Actually,
I
I
see
want to
questions
know
here.
if we have some of the tactics like we found in our environment.
Hmm.
Then I want to map these to MITRE framework to know exact who is the like adversary, or what are the other uh, techniques that is used, and my EDR solution or SIM solution is not able to recognize that.
Okay, your sim solution cannot recognize it now. So MITRE gives you a holistic approach, yeah, and your sim solution would not be able to recognize a lot of it. It's wholly based on detection engineering. Now how would a detection engineering team understand what kind of detections should I create for my organization? That is where somebody's asked a question, I believe, about attackers are pretty aware, and how do security teams outperform them, and what all to remember for. Okay, all right, I'll answer these questions. And who was that who asked this question? I didn't get your name.
Gulshan.
Gulshan. Okay, all right. Let me just. Yeah. So, from a SIM perspective, right? Your a detection engineering team would have to write detections or queries for your SIM tool to be of some use. A SIM tool is basically used to send logs from different multiple log sources. It would only be of value once detections are inbuilt into them or built into them. There are inbuilt detections, but it wouldn't cater to specific needs. Now this is where the team would open a MITRE framework, start making detections based on the cyber kill chain or the MITRE framework. Now cyber kill chain does not outline what a certain phase in depth has. That is where MITRE framework comes in handy. And from detection perspective, let's say a security team wants to understand, okay, I want to know if active scanning is happening on my organization. So a recon stage is something the security team cannot, if it is passive, right? A security team cannot detect because that is outside on the out on the internet. And like I already told you, the only way to defend from this stage is to limit information to the internet. Now from an active perspective, so when you create a detection which notifies or which alerts you when a scanning activity happens. So when an attacker tries to scan a certain IP block, so he would try to use let's say a flag which would a TCP scan. when you understand multiple, when you observe multiple TCP scans happening on your infrastructure, a blue, you create a detection which says, if I get, let's say, around X number of TCP scans within a 5 to 15-minute time frame from a specific IP address, or an IP address which is not in the allow list. What is an allow list? Allow list is basically a list which entails all the IP addresses which can be allowed to scan. So if a set of IPs which are not in the allow list is scanning, and is causing a lot of noise, you send out an alert. Now that is one, detection you create on the recon phase. Now resource development, detections on resource development could be something like, a typo squatted domain. Instead of miter.com, an attacker can, instead of an I, he can put in capital I or a small L, and this becomes a typo squatted domain. Um this at at a first glance nobody would notice it, but this is one way an attacker could create a phishing domain so that he can start harvesting credentials. So how would, on from a resource development perspective, what kind of detection can you make is, let's say, typo squatted domains, right? You can create a list of possible combinations, and have something like a detection wherein it observes a similar domain being created. Or let's say you have a miter string in the domain, so somebody can create a miter-org.com as miter framework. So you can create a string which says, you know alert us when you see a specific string or a registry, not registry, a reg expression, a regular expression string which would have a certain keyword. And if a domain is created, send us an alert so that the team can understand if this is a phishing domain or no. Most of the organizations, what they do is, because the cost of getting down a domain is very expensive than to own a domain, what they would do is they would own at least the evident type of squatted domains which would be owned by the organization itself. That way they don't have to worry about domain takedowns, because a domain takedown is more expensive than to own a domain. So that is one detection you can do on the resource development stage. But mostly detections are involved on the on a persistence level, like I mentioned. Let's say a registry auto start, a registry modification. So you would have a detection which says, if any modifications happen at this specific registry key, an alert is being created. That is one detection you can create. Creating an account. Now, creating an account, basically, if you're creating a privileged account, you can a detection is created. Um, let's say a new account is created with admin privileges, so there would be an event ID for it specifically tied to it. So based on that event ID, I don't remember the exact ID, but based on that, you can create, the detection team creates a query for the persistent stage. There are certain stages over here which is taken care by your EDR, so you would not need an overlapping detection query for that stage unless really required for a certain use case. That's how Yep.
Excuse me. Can you look at uh, logon autostart execution?
Okay. Lockdown.
Yeah,
Yeah.
yeah. So what are the necessary prevention?
Necessary preventions. Okay. So one would the most evident one would be a startup folder or registry run key. Yep. And the next one, print. I would say something common would be a login item, I guess. So you can, you know, utilize, this per- detection as well. So over here, it tells you how to detect it. So by a login item, what, you know, where is it created? It gives you from, this is, I think, on a Mac environment, tells you that at this file, an auditing should be monitored. So basically, you create an audit log. Linux has something called as an audit, setup where certain, files get, or a certain file path is being monitored, and you are alerted. And yeah, you can pivot off these. That's how a detection engineering, team or a security team uses the framework to basically create detections on, and yeah, make use of your sim.
So sorry, if this happen on a device, on a mobile device, is it the same
Mobile.
process? Yes. Let's say this happened to someone's phone. So
Hmm.
so how do you do that on a phone, for instance?
Okay. All right. So I'm looking at the matrix for an enterprise.
Yeah,
Now,
okay.
for a mobile device, you would have to, check what
Oh,
kind of, perspectives are there for a mobile device.
okay, that's
Again,
fine.
this would be, let's say for an iOS, OS perspective, for an Android device, what are the ways, an iOS device. So this is basically a vast topic. Uh, if you would want to understand in detail, basically, yeah, most of the details are on the framework itself, and
Okay,
you can pivot off from there.
okay,
This
that's
is
fine.
the mobile index, and it's also got for cloud as well. I don't, yeah, there you go. This is, let's say, for Windows specific detections, the team would refer this.
Okay.
I was showing you the enterprise matrix, which has everything. So yeah. Um, are there any other questions? Okay, from an interview perspective, all right, a common interview question would be, what is a MITRE framework, and give an example, or they would, pinpoint. Let's say, can you give me four ways how somebody can, achieve initial access, or two ways of how persistence can be achieved. So, you know, make a note of mainly persistence. Make a note of how persistence can be achieved. Go through, read through certain, persistence mechanisms. Let's say, yeah, common ones would, again, understand the registry path. That is a good pointer you can, point out at an interview. Browser extension is something which you can utilize. Then creating an account. By that I mean, these are the three things which have been pointed out. So you just give them certain examples. Next would be, yeah, an office startup in the form of macros or forms. So go through persistence. That is one thing you can go through. Then the next one would be, let me hold on. Okay, collection. That is something you can answer in the interview. So in collection, maybe basic examples could be copying data from the clipboard, and detections can be involved to create a detection wherein if you notice somebody copying data from clipboard, but it is I mean, at least from my experience, that has not been it is not a very, it's prone to a lot of false positives, so it's gonna create a lot of noise. And how is lateral movement achieved? That is an important question on your in your interview. So please understand the ways of lateral movement through these things outlined here. uh, Mostly lateral movement is through remote services. It can also be achieved through an internal spear phishing. That is, you once you gain internal access, the domain access, you do another phishing attempt to gain access to an admin account. Lateral movement, I think another technique would be to create a admin account. That is, from persistence you can create an admin account which gives you lateral movement as well. um, uh, by lateral movement, I mean, once you have an admin access, you're open to much more other tools within the infrastructure. So learn persistence, privilege escalation, lateral movement. For from an interview perspective, I don't think command and control is really asked. Exfiltration, just know the ways of exfiltration. And impact, not really. Main pointers would be privilege escalation, lateral movement, and persistence. So just know these few techniques and sub techniques. You don't have to really go in depth. What you can do is create a scenario. Let's say you create a scenario wherein it covers the entire matrix. One Take one pointer from here, and then move move to the next stage, that is resource development. You can either, like I mentioned, one is acquiring infrastructure. That it comes under, I believe, obtain capabilities, I guess, or establish accounts. Okay, it comes under one of these wherein you create, no, sorry, it's under acquire infrastructure. You create a domain, a type of squatted domain. So you can say, you do recon using OSINT, and then you acquire an infrastructure, or you create a domain, similar domain, and then initial access would be through phishing. You send a spear phishing email, or you send a phishing email in bulk. And execution would basically be, from a phishing perspective, mostly execution would be through these three, basically user execution. And you move on to persistence. How would you achieve persistence after that? One is, if if the phishing email was to obtain credentials of the user. Once you have the credentials, you can log in, and then y- you know have persistence to the account. And then once you have access to the device as well, persistence can be achieved through startup. Take an example of a registry run key, or a startup, or a browser execute browser extension. Privilege escalation, I don't use one of the examples. Most of the there are some things which are overlapped. So yeah. Now defense execution, from how would you sorry defensive evasion, how would you achieve it? Things like modifying your files, changing hide artifacts. You can use steganography. You basically, with that, you can hide data within an image. So use this, framework to build an example. It does not, ideally have to cover the entire chain. You can explain, a certain part, narrate a story of how an attacker can achieve it and how a defender can defend it. You don't have to go in depth as well. You would just get around 2 to 3 minutes to explain it. So yeah, just make good use of it. Phishing is the best example to give. All right. Any other questions? Okay, moving on. The incident response life cycle. So the y- for an effective, you know, cybersecurity assessment and evaluation, an organization would need to adopt an incident response framework. There are two frameworks, that is the NIST and the SANS. You really don't need to, both of them are similar, but depending on organization, they choose which framework they want. You don't need to specifically, be, you don't need to specifically know a certain framework, but knowing one would, obviously help. So, yeah, there are four phases. This is the NIST framework. There are four phases. First is preparation, then comes detection and analysis, then comes containment, eradication, and recovery, and post-event activity or lessons learned. Now, in the preparation phase, what is the security team or an organization looking at? So this is post, post pre-incident, not even post. This is pre-incident. Before an incident can happen, how should an organization be prepared? Let's say, policies are put in place. User awareness trainings are, given. Policies such as, technical controls or administrative control policies, wherein, user access control policy, that is, or, you know uh, you have an acceptable use policy wherein it states that what a user can and cannot do, and based on that, you know there is another policy which says, if an incident occurs, what teams to be notified, what government bodies are to be notified in case, and what actions need to be taken. So you create an incident response playbook as well. These are all created well in advance so that organizations are prepared for, you know if an unforeseeable incident occurs. Now comes to detection and analysis. At this stage, basically, an organization, utilizes its tools and technologies to, you know accurately detect and assess incidents. Now, this is detection. Like I mentioned, you use the MITRE framework to create detections on your SIM tool. Once your detections are created for each, you know techniques, and a security, team would be assessing these alerts created by the SIM tool. Now, how would once accurate detection has been established, analysis would be wherein a team, when you get an alert, you open an alert and you understand how this was, created, and based on the priority, you analyze the incident and understand if this is critical or no. And let's say if you find a true positive incident wherein a malware has been successfully executed, your detection software or your detection engineering team has created a query which alerts the SOC team, the security team. stating that suspicious file has been observed and written on the host and executed as well. Now your EDR was not able to identify it, maybe because it is a new malware and heuristics detection or signature detection never worked since it is something new. Now it is executed, but it is trying to reach out to, it's making suspicious DNS queries. Now, now, from an analyst perspective, you're going to understand, the network communication from the host, what kind of network connections were established, what domains are these. You do a domain analysis. I'm sure people are aware of how to do a domain analysis. You basically go to a domain tool. Let's say who is over here. You understand how old the domain was. So let's say I'm just going to take this as an example. All right. Now, when you understand suspicious or a lot of network, connections are being observed. Since this is a new malware, you use OSINT, that is virus total, or URL scan, the other tools to determine what this domain is. You're not getting any hits out of it because no vendor has flagged it as malicious. And domain tools says, the domain was just created recently, 100 days, 10 days, 100 days old domain, and it is suspicious because it is a new domain. You visit the website as well, it really doesn't have a web page of such, or it does not have any online presence. Or when you do an OSINT, let's say you want to do an OSINT analysis, right? You do a basic Google search this way, and you understand you don't get a lot of results for that domain as well. Now, based on your analysis, you understand it is through the actions of this suspicious tool which created these network connections. Now comes you move to the next phase, that is you decide, containment, eradication, and recovery. It basically means mitigating incidents. So how do you remediate these use cases? So depending on the use case, let's say it is a ransomware you know s- um attack, and your EDR is at least observed, notified you at the initial stages of the ransomware execution. It is sent an alert to the team. Now, the best way would be to contain that host so that it does not spread across. So you isolate the host from the network. That is something you do. And eradication and recovery. When it comes to eradication and recovery, once you understand the malware or whatever was installed, you take the hash of the software or the malware sample. You do proactive threat hunts to understand if there are any other computers which have this malware on the system. Use your sim tool to do proactive threat hunts. You can run a basic query using the SHA value to identify if any other hosts have this file written on it, and you can isolate them as well. Block that hash. When you block that hash on your EDR, it does not allow an execution on another host. So that is one step into the remediation process. A recovery stage is the worst case scenario wherein you require to wipe the device completely because it was a rootkit which is on the kernelus, and that is something which persists every time. uh, To be safe, security teams basically do a reset of the device when it is a very suspicious, if it's a new software or a malware which has been installed, you don't see it anywhere else. And based on how the software has been compiled, an organization also has a threat intel team and a malware analysis team who would analyze the sample and give out IOCs, wherein based on these criterias you would determine if a reset is required, and you completely reset it. By reset, you set the system to the baseline. You would have a baseline image of the host, or an organization would have a baseline image of how an OS should look like. They would use this phase to recover from that baseline image. Now, coming to post event activities or lessons learned, this is where a lot of them oversee this aspect of IR life cycle, because it is basically, most of the efforts have been done in these two phases, and this is mostly a notification phase. I mean, people consider it as a notification stage or a reporting stage, but here the main objective is to understand and learn and prepare from this stage. So once incident response efforts are completed and a report has been generated, now you would ideally a security team should see how we can improve you know our ways, so that a similar incident never happens again. So this is where revisiting of certain procedures or revisiting certain ways, a certain function works. Let's say a test team, an incident occurred because a testing team basically set up an account with no MFA and a common password. Let's say admin123, or just admin, username admin and password as well as admin. So this is where you would revisit and change your procedures, give out, educate teams to utilize security best practices to you know um, and follow them, so that a similar incident does not occur in the future. So this is mainly incident response lifecycle. From an interview perspective, just know these phases, stick to one of the you know frameworks, NIST or SANS. This is the NIST framework, and like how I explained the MITRE framework, give a basic understanding of each phase. Anybody has any questions?
Which was the other framework, NIST and which was the,
SANS,
could you spell for me? Science.
SANS. I'll just
Okay.
try getting it up. So this is the SANS framework. So it is basically the same, but this has the phases you know broken down even further. So you either follow the NIST or the SANS framework. These are the two frameworks, side by side. So yeah,
Oh, okay, got it, got it, got it. Thank you.
yeah, stick to one framework. Give a basic idea of why. Basically, give a basic idea of why an organization requires an incident response lifecycle. This helps them prepare for cybersecurity incidents much better than in an organized way than when an incident occurs. Nobody knows who to contact, nobody knows what to follow or how to even investigate. So this is why a framework was established, just to at least have standard protocols. Yep. Any other questions? All right. Okay. Coming to the next concept, which is the CIA triad, which is, you know, from an interview perspective and from security perspective, is a good, you know, thing to know. So CIA basically stands for confidentiality, integrity, and availability. And what does confidentiality, you know, mean? From a definition, it basically means that a certain or a set of information which is only accessible to people who are required to know on a need to know basis. So, or who's authorized to have access to know it. So this metric, I would say, is required so that it is designed in such a way you can understand it is to prevent, you know, unauthorized disclosure of information. And how would you ensure confidentiality? That would be through, you know, encryption. I'll come to encryption. You know, there are types of encryption. So when you encrypt data, and let's say only a specific set of people know how to, you know, decrypt it to read it, this ensures confidentiality. And access controls, basically, you know, role based access controls. Let's say in an organization you have 3 4 different teams. The engineering team would not need to know, you know, details or pay information about other employees which the HR team would have access to. So this is where, you know, you do role based access. HR team has access only to HR related information. Engineering team has access to only engineering, you know, related tasks and nothing more. So yeah, data masking is another way to, you know, ensure confidentiality. So it basically, you know, converts an important data. Let's say if it is a credit card information which is, you know, written like this, it would be masked with X instead. And only if you have a key would you be able to see the data. So that is where data masking comes in. This would be like you know, a DLP kind of a solution which can be utilized. Now moving on to the next you know, that is integrity. So integrity, basically, the main objective here is to understand if the information sent from person A has not been tampered while in transmission and has been received as is, you know, to the recipient. So it is basically to maintain the accuracy and to understand if unauthorized change of data was involved. Now, how would you do this is hashing. As we all know, hashing is basically a one-way function wherein you given a certain, you know, variable, it gives you a fixed output hash, and it cannot be, you know, decrypted or to you know, read what the actual data is unless somebody knows what kind of no, you basically cannot. So how does it work? In a transmission perspective, let's say I am sending something across to a person A is sending across something to person B. Mm, all right. Let's say, you know, A is sending something to B, and all right. A is sending a certain set of information to B. Now, how would B know what A sent over the internet is what he sent, because there could be a man in the middle attack as well. So surface level, before I get into encryption, I'll just clarify this out, the integrity part. So A would write a message, send it to B. A would also give the hash of that message. Let's say I would convert you know whatever I've written, make a hash of it, and the hash of the message would be something like this would be the hash of the message. And A would send B the hash through a different medium, let's say through a secure medium. A sends the hash of it. Now when B gets the message from A, what he's going to do is run a hash of the message. And if B's hash and A's hash, A would also tell B what algorithm was used. So if, when A and B runs the same algorithm on the data, and if the hash remains the same, it basically means the data was not tampered. Now, from you know, the other ways to maintain integrity are version control. That is, you track changes, which has been made. How do you do version control? There's something called as a file integrity monitor. It's called an FIM. This is something which would track changes in a file directory. If you have set it up on your organization, it tracks file changes, and it would notify saying, let's say a core system which only has limited access. This is where you would implement file integrity monitoring, so that any small change which is not authorized can be you know uh, n- identified at an early stage and remediated as soon as possible. So this is where integrity comes in, and availability is basically ensuring the systems are available when required. So how do you maintain availability? Redundancy. So that by redundancy, have failover mechanisms. An example of redundancy would be something like a load balancer, uh, or you know another example would be, let's say, an organization has a firewall, only one firewall. So make sure you don't have single point of failures. So if this is the only one firewall an organization has, if this fails, the organization is prone to attacks now, because the firewall isn't working. Not only prone to attacks, nothing is going to go past the internet because it is not going to pass through the firewall. So always have a mechanism, that is, now have two firewalls running in parallel, and you have a system health monitoring check which says that if this does not if this reaches its potential, you know it diverts the traffic to the next firewall. This can be used in a balancer perspective as well. That is, you see a database, consider this as a database, and these are your load balancers. um, this is a database which your users or users from the internet access. Now a load balancer would try to, you know if there was no load balancer right now, and the database has only a limit of, let's say, 1,000 connections per minute, and it is now getting overwhelmed because it has already reached that threshold, and things start to get slow, or worst case, the database goes down. This is where a load balancer comes in. So the load is equally distributed to the database now, and it also restricts connections as well. This way, you ensure that the database is available at all times. Disaster recovery planning. This is something organizations also have. There's something called as a hot site and a cold site. So basically, let's say due to natural circumstances, your data center is flooded or affected. Now you would need a backup running. So this is where people would have a backup data center, which is a cold site or a hot site. A hot site is wherein everything is already established. You just need to get in and power on, and everything works as normal. A cold site is where only you know a bare metal infrastructure is involved. That is, you have a database, you have networking servers and stuff like that, but it is not functional yet, because you would need you know uh, you need resources to utilize, make it operational, and it is not a it would have a downtime of a certain, based on how it is set up, it would have a downtime compared to a hot site. So yeah, this is where, and maintenance and updates is, I think that is something which happens, should happen regularly, so that systems are you know um, up and running all always. Do you guys have any questions on the CIA triad?
Yeah. Please let's look at integrity.
Okay.
How does checksums work on integrity?
How does a checksum work? Okay.
Yeah.
All right. Checksum basically on a, so it is basically a, what I explained. Where Okay. So when you run a specific, you know, plain text,
Okay.
that is, mm, I'll
Can you please open that slide?
Slide 13. Yes.
just a second. I'm just trying to. So let's say FIM is the data which is given. Yep.
Hmm.
And now I would run it against a hashing algorithm, that is SHA-256. I would get a specific output. Now just consider this is the hash of FIM. Hash of FIM when ran on a SHA-256 algorithm is this. Now when when this is transmitted over the network, and the the recipient, when they run the same algorithm across, and they get the same you know checksum value, it means that the data has been transferred completely, and there was no error in data transmission. That is one way you validate that the checksum was right. So this is basically a hash sum, and that's how it is. It's mostly used in a TCP transmission. I hope I answered that.
Okay.
Yep. So you guys might have noticed, let's say, when you download a certain software, right? You would find the hash of the software. Have you guys noticed that anywhere?
Yes, sir.
Yep. So basically, what happens is, I'm not able to find a website which I can.
Uh, Like when we are downloading Splunk, there is mention MD5 hash.
Yep. Okay. I think not sure if I can replicate it in this website. Let's see. All right. So basically, it has a SHA hash sum or a MD5 value or written saying that this is the hash value. When you download it, what you do is you run it across a hash tool, and when you get the same value, you understand that the software or this website has not been compromised, or the software which has been uploaded, you get the right software. You're not redirected to a different website and you're downloading a different software. So this is how you verify it from websites. uh, yeah, I mean, these are, yeah, I think. Any other questions?
No.
Okay, so I'm going to move to encryption now. um, so I think we had a basic understanding of encryption. Now what it does is it converts a plain text into a ciphertext using a specific algorithm. Now there are two types of encryptions, which is symmetric and asymmetric encryption. Now encryption, as we know, is mainly used for maintaining or you know maintaining confidentiality, so that the intended recipient receives it and nobody else. Now how would coming to symmetric encryption. So what does symmetric encryption basically mean? So it has one key which does both functions, which is encryption and decryption. And now the challenge of symmetric encryption is there is it's an advantage and challenge basically is the key exchange. Now while exchanging keys to somebody over the internet, you cannot use symmetric encryption because you know the same key is used for encryption and decryption, right? If the key is compromised over the internet and it it results in unauthorized access of information. So mostly symmetric encryption is n- never used for transmitting keys over the internet, but it is used to encrypt the data if there is large amount of data. If you have large volumes of data, symmetric encryption is used. And now key exchange, when it comes to key exchange, that's where asymmetric encryption comes in. So so in asymmetric encryption, two keys are used, which is a private and a public key, and based on and data can only be decrypted with its corresponding keys. So let's say I'll just give you an example of. All right, let me just use paint instead. Okay, so this is your plain text, and it goes through an encryption algorithm. Let's say you use your um this is person A. He's using his public key, okay, to encrypt this data. Now it is transmitted over to the internet and to a recipient B. Now, two, hold on, I think I just got it mixed. So A is encrypting a certain amount of data with his private key. Um, as eraser. Okay, I'm bad at paint. If you guys haven't noticed it yet. All right. So this is the private key. Yep, and it is sent over to the internet, and it is sent to a person B. Now, for B to get this data in clear text, he will need to decrypt this information. So let's say this information called P has been encrypted with A's private key. Now, the only way to decrypt it is with A's public key. Now, the concept of private key and public key is um, private key is, you know, private key is open to the, sorry, private key is kept only to the recipient, or it is only known to that particular person. Public key is out on the internet. Anybody or everybody can have access to your public key. So when you transmit data, you always use your private key to encrypt data and send it over the internet. Now, when B needs to decrypt this, B already has your private key. So he's going to use your private key and, unlock the details, that is, decrypt the data, and he gets the actual data which was transmitted. So this is where encryption is used, asymmetric encryption. So the main idea of asymmetric encryption is just to do a key exchange, because asymmetric encryption is really slow when it comes to large amount of data. So mostly just to have a key exchange set up, people use asymmetric encryption and then move on to, by key exchange I mean to exchange the symmetric keys. To exchange symmetric keys, they use asymmetric encryption. Once symmetric keys have been exchanged over the internet, then they use the symmetric key to decrypt or encrypt data. So that's the concept of symmetric and asymmetric encryption. Do you guys have any questions on this?
How does this private key is shared between two people like sender or receiver?
No, like I said, private key is never shared. Private keys, if I'm sending something, private keys just with me. I'm never going to share it.
They decrypt it.
Pardon?
How will the receiver decrypt the message? Because he'll
Yeah.
use private.
So when I encrypt it with my private key, right, it can only be decrypted with my corresponding public key.
Oh, thank you.
Don't get confused with symmetric encryption. So symmetric encryption only uses one key, whereas asymmetric encryption uses two keys. So a public key can be shared openly, while the private key is only kept by the owner.
But the
So
first
How
line
does the
says,
receiver decrypt this asymmetric key using asymmetric key when he doesn't have that key?
public
I
key
mean to
is
say
open to
private
the
key.
internet. No, okay.
See,
So
you're sending some data using an a private key. Let us say A. Okay,
correct.
then I have a B as a public key through which I can decrypt it. Right, that anybody can do it. Right,
No, 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 no. So I am using A's public key to decrypt it, not B's public key.
but
but if you
everybody
go
will
and
be having the access to the A public key. Right.
Correct.
Instead of B, anybody else can C, D or can also
Yes.
decrypt it, right?
Yep. Uh, I was getting to that. That's a nice call out. So over here, right, when you're talking about the CIA aspect, in this perspective, as you pointed out, confidentiality, is it maintained or no?
It's
Yes.
not maintained. Is it maintained? Since anybody can encrypt it, so it's not maintained.
Exactly, it's not maintained because anybody can encrypt. A's
Yeah.
public key is open to the internet. So when he's decrypting this with A's public key, it doesn't have to be B who's decrypting it. It can be somebody else on the internet who's decrypting it. So confidentiality is not maintained. Now,
Mm-hmm.
if you really want confidentiality to be maintained, it goes the other way. That is, if I want B, so let's say I want B, I only want B to access the information. I Is this diagram confusing?
Yes, somewhat.
Pardon?
Yes, somewhat. It's confusing.
Okay, I'll just try. Mm, okay, this means A is public key, and it's transmitted over the internet. This is the second example I'm going to take. So let's say A wants to send. I'll get to the previous example which I drew on the board as well, on the paint. This is the second one. So A wants to send something only to B. Now, how would he do that using asymmetric encryption? He would use B's public key to encrypt this plain text, yeah, to a ciphertext using B's public key and transmit it over the internet. And B would, you know, get this as plain text using his private key because he's the only one who's got the private key. So in this phase, uh, what are the three things which are maintained? Or based on CIA triad, right?
Mm-hmm.
Confidentiality, integrity, and
Right.
Mm-hmm.
what do you guys think are maintained?
Confidentiality, confidentiality is maintained.
Okay, what about integrity and authenticity?
Integrity
I'm
is
gonna I'm
maintained
gonna
as well.
use instead of availability, I'm gonna use authenticity in the CIA triad for now. So yeah, what about integrity and authenticity?
Yeah, integrity is maintained, and
Don't you think integrity and authenticity are the same thing if we are using authenticity instead of availability?
Yeah, uh, is it maintained or no?
integrity is maintained
Why would you say that?
because sender A
Hmm.
use recipient B key.
Okay.
to send the message.
Yeah, I would say, integrity would be maintained, when there's a checksum involved as well.
Okay.
So that, A knows that, sorry, B knows that whatever A sent is same when he does a checksum or a hash, comparison. But holistically, right now in the CIA, with authenticity as well, by authenticity, I meant, does B right now know if A was the one who sent the information to B?
No, sir, in this diagram, no.
No, because C can use B's public key and send information to B as well.
Mm.
So authenticity is also not maintained. Uh, so
For
yeah,
integrity purpose, B has to send his public key to A, and then A has to
no,
means
it wouldn't be maintained
make
that way. Even if you reverse it, there's a specific thing called as a HMAC. What happens is it is a little more deeper. It would just get you guys confused. So just know the key exchange process. Uh, the integrity and
Okay.
authenticity part would basically happens through something called as an HMAC function, and multiple layers of uh, encryption happen while transmitting. That's and multiple layers of decryption happen. That is, one layer would be, it is a deep concept. I don't think it's just going to get you guys confused.
Mhm.
So yeah, the main purpose, just understand the confidentiality perspective of sending information. So in this way, B knows that, I mean, A knows that B is getting the details. A is confident that only B can decrypt it.
Mhm.
So here confidentiality is maintained that way.
Mm.
But the other diagram, which is, I'll try to change it, is private key. And yeah, over here, A is trying to send a plain text which is converted to ciphertext with A's private key, because A is the only one who's got his private key. Nobody else has access to it. And it is sent over the internet. B decrypts it using A's public key, and plain text is obtained. So over here, confidentiality isn't maintained.
No,
Yep.
I will say no.
Yeah. Anybody else has something to add to it?
So can I add something to it, sir?
Yep.
Actually,
I
please,
can't hear you. Could you be a little loud?
yeah, please show the screen, sir. I'll explain on that same part.
Okay.
What actually happens is when A wants to send some data to B, actually A requires B's public key. So A requests from B, please send your public key as well as private key. So what happens here is the B shares his public key to the A. So what A does is A actually encrypts the data with the B public key and sends the data to the B. So now here B decrypts the data with the B owns private key. This happens in the asymmetric this thing encryption part. So what exactly happens is when someone needs to collect data, then they would share their public key first of all to the sender. Then the sender will encrypt the data with the recipient's public key. When he encrypts the data and send it back to the recipient, then recipient will decrypt the data with his own private key.
Yeah. I think
Hope
that's what I was,
it's a
inferring
little
on
bit
the
clear.
previous example. This is a different one. Were you
Yeah.
trying to share something specific?
No, sir, no.
I mean, your understanding is correct. Were you trying to add something to it?
That's it, sir. That's it.
Nothing. Okay. Yeah. That's exactly, what it is. So that was the previous example you were talking about. I've, changed the
Mhm.
private and public keys across right now. I'm using A's private and public key. And here confidentiality is not maintained because A does not know who's reading this information. Because see, a public key is meant to be public.
Yes.
Anybody on the internet knows it. So if I encrypt data with my private key and send it across to somebody, someone with my public key and can easily decrypt it and read it,
Hmm.
and maybe change something and then send it. Okay, the change something wouldn't work because they would have to. I'll have to again encrypt with my private key, which uh, somebody wouldn't know. So yeah, here confidentiality aspect is not maintained because it is not going to the authorized user, or the data is not being sent to the intended recipient, but to anybody over the internet. So yeah, I think this is all I have for today's class. Do you guys have anything, anything, any specific concept I can maybe explain, or from this session, or anything you've got from, let's say, your interview perspective? I can maybe add on.
Can you please throw some light?
I can't hear you. Could you be a little loud?
Can you please explain the heuristic analysis or heuristic analysis, sir? Heuristic
Heuristic
detection.
analysis.
Yeah.
Okay, heuristic analysis is not something, you know, it is a machine learning algorithm. Okay. So let's say, um, how do I put this in an example? Okay, heuristic detection is used, with the help of machine learning model. It tries to understand, how a certain, it tries to understand a behavior. Basically, heuristic in simple terms means behavior, you know, detection. Now, let's say when it comes to ransomware, right? Ransomware has this uh, behavior of renaming files. Now, if this is a new ransomware sample, what an EDR would do is, let's say EDR works based off signatures. EDR is basically a fancy antivirus solution. It has signatures in it. It's got its threat intel, sources, which is adding IOCs to it. Basically signatures. Also, add-on is a heuristics to EDR, and it's got response capabilities. So in heuristics, what it does is, if nothing matches the signature, right? Now, since the EDR is continuously monitoring a certain host, and it detects file changes in a specific directory. Now, the EDR is gonna, understand that file changes are happening, and it is following a certain pattern, and based on whatever behavior modeling, it thinks it could be, ransomware. Now, heuristic detections are not always, 100% true, but the confidence level is fairly, right to at least start off with an investigation. So when it sees file renamings happening continuously, it sends out an alert. You would, start to understand where the file path and the directory through the EDR. And now you understand the host as well. What kind of a host is it? If it's an, if it's in an engineering department, you try to understand what file names are. Is it having weird file names? If it is weird file names, basically it could be something suspicious. To investigate further. So yeah, this is how heuristics. A basic example of how heuristics work. It's based off behavior. It tries to understand something based on what it is thought, and triggers an alert, and
So,
it needs an
there is no human
analysis.
interaction.
Yep.
So there is no human interaction in this.
Human interaction, no. By human interaction, you mean to, it's a machine learning model. It is a SaaS based product, and EDR is a SaaS based product. So The only human interaction is teaching the model, a machine learning model, and to understand what a certain behavior is. That's it. From an analyst perspective, human interaction would be to understand what the heuristic detection is, and take it further based on your analysis, and confirm and identify if it is a true positive or a false positive.
Okay, sir. Thank you, sir. Thank you, sir.
Okay.
Just a quick one from me.
Yeah, sure.
So let imagine you have an interview as a
Okay.
SOC analyst or cybersecurity analyst,
All right.
and the interviewer asks you, "Can you tell me quickly about yourself? What are the key
Mhm.
points you think you can, you know, chip in to,
Okay.
to make first impression, good impression to the interviewer?"
All right. Alex, just to understand further, do you also have work experience?
Yes, I currently work as a NOC analyst.
Oh, perfect. So, see, if you're working as a NOC analyst, I'm assuming you're trying to move into the security space with the NOC
Yes.
experience. So, your first, in your introduction phase, right? Explain. Don't go in depth into your NOC perspective. Just know that you don't need to share that expertise to the interviewer, but give them a fair understanding of how many years of experience you have, and what on a surface level, what do you do in the NOC team, and how it kind of overlaps with the security role as well, and what kind of tools you use. Let's say if you know from the job description that a specific thing is used. So from Knox perspective, you would be good at the networking side of things, right? You can maybe start off with giving a brief introduction of your experience, and what made you interest into, or why you try and transition into the security space. It really depends on that. And the concepts, I think these concepts which are explained, right? Just have a good always don't stick to a definition, I would say.
Okay.
Even though you know a definition, don't stick to a definition. Always have an example instead, and relate to the definition. So that would make somebody from an interviewer's perspective, they would know that this guy has an understanding of the concept, maybe does not know the definition, or it doesn't have to be that way, but he more he can relate to it than giving a definition. So if you're giving a definition, anybody can give a definition. I cannot judge you based on a definition, right? So if you put in, let's say, when they ask about a MITRE framework or incident response lifecycle, why is it put there? Why do we have a framework over there, and how is it important to follow it? If you can explain things like that,
Mm.
it basically says that the maturity or the level of understanding of this person is pretty good, and we can give him a chance. So yeah,
Okay.
but always be thorough with your security basics. I think Security Plus would be a good. I'm not saying the certification, but you can learn the concepts in Security Plus.
Mm-hmm.
That is absolutely helpful during interviews. To relate to a lot of things. You can there's free resources on YouTube. You can relate to Professor Messer. Learn Security Plus from there. Yeah, that should that basically helps with a SOC analyst role.
Thank you.
Yep. Anybody else has anything before we wind up?
If anybody asks in the interview like about the cyber culture, so in place of definition and all, how can I give the example on cyber chain so that he can easily understand? Okay, I know about the concept. So can you please give the a brief example on cyber culture? Or
Yeah, so you can start off by saying it is a model used to from an attacker's perspective. It is a model used so that he can he, these are the faces he uses to carry out a successful attack, and it consists of these many steps. Just explain the steps first, not in detail, just call them out, and then you tell them a recon by definition. This basically means gathering information. Now, gathering information, you don't need to go in depth by saying active or passive. Make your example easier and just stick to the passive space. That is, by recon, let's say you make up a target. I'm going to target someone called as B. So now I try to understand what information is available on the internet for B. Based on that, I try to craft a specific weapon or a payload. With this payload, I'm going to now see avenues to deliver it. Now here is where you can leverage what are the ways of delivery. Always stick to common examples, so it's easier to relate. So common phases of delivery are phishing and USB. So explain that. You can also give them a statistic saying that I'm going to choose phishing because that currently seems to be at least successful compared to other attacks. As per your reading articles and blogs. Now, once the delivery stage is completed, it comes to the exploitation, installation, and command and control. I wouldn't specifically, start explaining exploitation, installation, command and control in one go. I mean, one by one. I would, club them together into one phase. That is, exploitation would be, the weapon which was delivered, successfully is now going to be utilized to install on the target victim. And once a successful installation and persistence has been obtained through, again, now when you talk about persistence, give them an example of how persistence is obtained. Refer the might kill chain if you want to understand how persistence is obtained. Take one example. Common example is always a boot login or auto startup. So use that as an example. And command and control. Now this is where an attacker would try to communicate with the host once persistence has been achieved. So he's going to give in information, or given information to the victim host to perform certain set of activities to complete his actions on objectives. Now this is how you know move through the phases with an example. Take a simple example, relatable one, explain it. And certain cases where you're using terms, try to see if there's something you can relate to the MITRE framework as well.
Okay, thank you.
Anybody has anything else?
Hello.
Yep.
If the interviewer will ask what is the difference between cyber kill chain and mid-threat attack, what you will say?
Okay. So cyber kill chain is basically an overview of how an attacker tries to, you know, achieve his objectives. Basically, it has 7 phases, but when it comes to MITRE framework, it is a knowledge base, and it has sub techniques and tactics within
Mhm.
each phase of the cyber kill chain. You can tell them it is an extended version of cyber kill chain, and it's got sub techniques and tactics which can be used. So this can be used from a you know defender and an attacker perspective as well. Why do I say from an attacker's perspective is whenever red team is trying to do an internal exercise, right? They often try to see the MITRE framework and see if what are the ways they can do something. Let's say from the privilege escalation phase. So yeah, this is what you can explain. Extended version, MITRE attack is always an extended version of the cyber kill chain, and it's got techniques and sub techniques. These are the tactics for an attacker to achieve things, and this helps. MITRE helps from a defensive perspective to create detection queries. Also, from an incident response perspective, let's say you you are aware that, or that your organization has been attacked by a certain APT, APT group. So let's take an example of APT 29. I think it's a Russian. Yep. So APT 29 has been involved in SolarWinds attack. They're also called as Cozy Bear or the Dukes. You don't need to know all these details, but from a if you know that APT 29 was something which was infiltrated into your infrastructure, now you know what are the techniques used by them. Based on that, you can try to do threat hunts and incident response. Like, how do they achieve persistence, or how do they achieve privilege escalation? So these are the techniques which this could be initial access, which through brute force, or it could also be lateral movement, once they have initial access. And this is again establishing persistence or you know uh, privilege escalation. So this is where MITRE in-depth helps you, because it is a knowledge base of all the groups. By groups, I mean APT groups. They're called as advanced persistence threat actors. Uh, yeah, and MITRE also has like matrices. It's got, for different OSs, it's got different matrices, or tactics and techniques, which your cyber kill
Yeah,
chain would not be able to give you an in-depth detail.
yeah. Thank you, sir. Thank.
All right. Anything else from anybody?
Sorry, just a quick one from me.
Sure.
Someone asked me a question a few weeks ago with regards to state sponsor attack. Like you show me, like
Correct.
you just show Russia now. And the young lady asked me, why state sponsor attack? Can't you have a legal action against them? And I was laughing. I don't know the answer. So is there anything you can do you have anything you can say about that? Sorry.
Yeah. See, questions like these basically are more general knowledge base. So when you say state-sponsored attacks or nation-sponsored attacks, right?
Yes.
These are involving different geographies or countries. Now, law enforcement is not uniform across entire across the globe. Um, the reason I say this is because in Russia the cyber laws are placed in such a way that you can attack anybody else but not the country.
Hmm.
So any cyber crimes committed outside the country, even if you are caught, you cannot be extradited to the let's say they
To the
don't they don't have an agreement to extradite to the country where the crime was committed. So basically legal challenges. So that is it's more of a general knowledge question, and you can just tell them law enforcement challenges, and yeah, that's how you can answer that.
Okay. Thank
Yeah. Hello. If
Yep.
interviewer ask what you will do for yeah, means these incidents and all lesser incidents or something, they will ask the questions.
What incidents? Lay
How
3.
to means how to reduce the incidents?
Oh, how
If
to
interviewer
lay
ask
3.
what will do,
Okay.
what will
So basically, how to reduce false positives is what they're trying to ask, and this is where it really depends. Okay, reducing false positives is trying to understand the alert first, why it triggered, and one basic example I can give is mm, let's say Okay, suspicious, you know, activity in your infrastructure. All right. Now this is coming from, or a suspicious scan happening. I think I'd explained that before. A suspicious, scan happening on your infrastructure. You get an alert. You get an alert every day now. Now, you see what the IOC of the alert is. What is triggering that alert? This is where you need to understand what the detection basically is trying to do. Once you understand what the detection is trying to do, you see what the IOC. In this case, if it is an IP outside the internet or outside the organization space, then it is suspicious. Otherwise, it is not. If your organization's vulnerability scanner is trying to do a scan and that is triggering your alert as a suspicious one, what you need to do is whitelist it to reduce the number of alerts for that specific use case. Similarly, for other use cases, this is how you basically do it. Understand the detection query. This is how we can
Yeah.
answer them. Understand the detection query. See if there's some unique value you can identify out of it, and try to see if you can either whitelist it or ignore it.
I was thinking
Yeah,
of,
thank you.
sorry, I was thinking of what happen if we update our correlation rule. Can that also help us as well?
Yeah. I mean, updating the detection engineering rule. Is that what you're trying to say?
At times we write some correlation rule to detect
Correlation.
some.
Exactly. Yeah.
Yeah. So what
Yes.
happen if we update our correlation rule to filter away some of the alerts?
Exactly. That's by correlation rule, detection rule. They're
Yes.
they're all the same. So yes, basically you try to modify your
Yes.
detection rule or a correlation rule
Yes.
in a way that it reduces it. By how?
Yes.
I think sim tools have a list verification as well. You can parse that list, or you can do something like, if the value is within this IP, ignore, something like that.
Hmm.
So
Yeah.
yeah, you can give vague examples. Nobody's going to test your query on an interview, but it's more of your logical thinking.
Okay.
Yeah, thank you.
All right. I think, any other questions before we end this session?
If someone asks in the interview, like, okay, I gave the example, I got the email and all something, ransomware and all. Uh, if interviewer asks, okay, you find the ransomware, you isolate or remake that specific system which like ransomware received on it. If you ask like what is the lateral movement you will do or you did if you received the ransomware? So how will I answer that question? What is the lateral movement I will do or I did?
No, I don't think they would ask you what. Are you talking about lateral movement?
Yes, lateral movement.
Yeah. So lateral movement would not. You wouldn't be doing any lateral movement, because lateral movement is from a threat actor's perspective, right? So your main idea is to contain it, isolate it, so lateral movement does not happen. Also understand what kind of host is compromised, to see if it has any critical, credentials, critical access, stuff like that. So when you isolate it, it cannot communicate to other resources. So from a blue team perspective or from a SOC perspective, right, lateral movement is not a question, that would arise.
But
Uh,
one interviewer asked me the same question. What was the lateral movement, or like if you got the ransomware and malware, or you like isolate that specific device and you like block IP and all on firewall and proxy or whatever tools you are using. But what if any other colleagues or user receive the same
okay,
ransomware?
okay. All right. The Got it. So here, right? Now you understand what the what solution or what malware samplers installed, and you have some IOCs which you mentioned you already blocked them, right?
Yes.
As I stated earlier, you do a proactive threat hunt on your SIM tool. One is for your IOCs which you obtained to see if any other hosts have these IOCs, and IOCs also include the SHA or the hash value of that particular file which was installed, which is the ransomware, to see if any other hosts have it. Any SIM solution or an EDR solution has that capability to identify similar files within the environment. So this is what you would say to pivot your investigation further to identify other affected hosts. You grab on the IOCs and try to we work on what we know. So that is IOCs are something we know and which you've blocked. After blocking, you do a proactive search within your SIM environment or your network using SIM. So that should be your answer. That is not basically lateral movement. That is what are your next steps, apart from doing blocking. So yep.
But if you are working as an album, this will be not my work, right?
This would not be your work, but you know don't be constrained by saying that L1 just does this. It's always good to know what happens on the next level as well, on the next stage, and also the detection engineering stage, so that way somebody knows this guy has an whole holistic picture of how a SOC works, not just how an L1 works. So please try to understand how L1 works. If you're aiming for an L1 role, definitely, but always be open to understanding how the other functions work as well.
Okay, got it.
All right, I have a question which says, how do you handle phishing email which has both link and attachment? What actions do you take? Now, you I'm assuming you guys know how to analyze header and analysis. Now coming to links, you see you use OSINT, virus total, URL. If you have a sandbox, utilize that. Run the attachment and the link over there. Again, take the hash of the attachment, run it on your SIM tool to see how many other users have downloaded the attachment. Another way is your email security solution would obviously have a filter called as attachment name and attachment SHA value. So you can put that SHA value to understand how many users have received it. If it is malicious, first action would be to quarantine the emails. Before quarantining, understand if it is a credential harvesting link, block the link first. Priority is to block the link first, understand how many users have hit the URL. You do no questions asked. Even if the user has just visited the URL, not done anything, you basically out of precaution you proceed with the password reset. That's basic actions you do. Again, depends on organizations, but on an interview you can just state this. You reset their credentials if you find them on the proxy logs. If you find them visiting this URL, you do that. Remediation measures are blocking the hash so that nobody else can download. Even if it's downloaded, they cannot execute it. Blocking the URL so no other, you reduce the attack surface. Quarantining the emails, blocking the sender, blocking the domain. Now again, sender and domain blocking, it depends. If it is a Gmail domain, you do not block the domain because it's a common domain. You only block the sender. If it is a new domain which is created, you block the domain based on the business use case. If this domain has not, you do a volumetric analysis by understanding how many emails you have seen in the past from this specific domain. Let's say last 2 months, I've only seen 3 emails and not even related, just random subjects. Then this can be blocked. But if you see a domain which has you know constant communication and just one of it seems odd, you can assume that the that specific account would have been compromised. So you can just block the sender for now. That is one way you do the remediation action. So yeah. All right, guys. I think we've reached the end of the session, and yep. I hope this was useful, and I hope you guys use this in your interviews as well. Yep.
Thank you very much.
Thank
Yep.
you.
Thank you
Thank you.
very much, Joel.
Thank you.
Thank you very much.
Yeah, thank you,
All
Joel.
right.
Thank
See
you,
you
sir.
guys.
Yeah, bye.